So next, I'd like to invite Ibu Retno Dewanti, SSE, MM, and PhD from Bina Nusantara University to provide a welcoming speech to all of us. Ibu Retno, the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Semua. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Good day, ladies and gentlemen. A very warm welcome to the International SDGs webinar held by Community Development Academic Center of Bina Nusantara University, Jakarta, Indonesia. I would like to warm welcome our distinguished guest speakers in International SDGs webinar series, Ms. Amalia Madihi, Mr. Muhammad Fahmi, Ms. Esther Widi Andangsari, Ms. Atsina Vibra, Ms. Rosi Kadiska, Ms. Vladimir Stevak, Ms. Desidera Cempaka-Murti, Mr. Ford Lumangau, Ms. Ratna Dewi Paramita, Mr. Thomas Siwerski, Mr. Alwar, Mr. Tota Pitokasi, and Mr. Fergianto E. Gunawan. It is a privilege to have you all excellencies, distinguished representative as change makers. I'm really proud of all of you. We are all gathered here to share and discuss the experience of SDGs programs across the region and beyond. Binus University, as a part of higher education, committed to full actualizing SDGs that are in line with the mission of Binus University, fostering and empowering the society. According to Goal 17 of SDGs, that partnership and conducted by mutual collaboration to ensure cooperation and innovation in this rapid growth era. Surely, we need the excellent strategy to improve skills through social, economic, and ecology. For 40 years, the university has made significant improvements in the actualization of Sustainable Development Goals programs and has a long-standing reputation as an initiator of 3+1 program, which enables students to study on campus for 3 years and then 1 year to gain experience of campus. Furthermore, to some extent, the government also applies a new approach called Campus Merdeka, or independent campus where students from one university can also transfer and study at their partner university. This will enhance student skills needed in the workplace from either through the internship, startup incubators, study abroad, community development, or involvement in research. This has proven 89% of Binus graduates already have had permanent job after they completed their studies. We are proud to have community development in 8 villages to support social, economic, and ecology programs, and facilitating business skills to improve more than 400 small medium enterprises, and also developing the competencies various community like government employee, professional skill industry, teachers and students, community, and others. Through this webinar, I would like to welcome all participants to get involved in our SDGs programs. This may only take place in the presence of a specialized and comprehensive mechanism for sharing knowledge and best practices. Your exchange today will open new avenues to strengthen the Sustainable Development Goals. Our discussion today and at major events in the months ahead can lead the way to greater commitment and action. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Right, thank you very much, Dr. Retno Dewanti, for the welcoming speech. And next, it is part of our culture to show highest appreciation to our founding father to these nations. And it is a part of our culture to start all event at this level by singing our national anthem Indonesia Raya. For that, I'm inviting you to join me in showing respect and sing Indonesian Raya, Indonesian national anthems. All right. Without further ado or further delay, let's start our discussions for today's topics about ecology. But first, I apologize for having to mute you all the audience. But we open one communication channel via the chat window where you can leave question or comment. And later on, I'm going to read those questions or comment to our guest speaker. And I also like to remind you all attendants to fill in the attendance form. And this is one of the requirements for you to get attendance certificate. So let's start with our first guest speakers. And we would like to welcome Thomas Siwerski, PhD, EEN from Lodz University of Technology to deliver his sessions. But before that, allow me to read in a few minutes a curriculum vitae of Dr. Thomas. So Dr. Thomas Siwerski was born in Lodz, Poland in 1963. He received his Master of Science in Electrical Engineering from Technical University of Lodz in 1988. And a PhD degree from University of Pavia in Italy in 1996. He started his academic career at the Institute of Electrical Power Engineering, Technical University of Lodz in 1989. From March 2001 to September 2003, he completed his postdoctoral research working as a research fellow at the Strathclyde University, Glasgow, the United Kingdom, with a focus on electricity market analysis, modeling, and simulations. In 2004, he became a senior lecturer at his parents' university. Presently, his research deals with modern power system analysis, power system economic, electricity market, grid issue of renewables and distributed generations, development of the concept of smart grids. Dr. Thomas Siwerski is an author of more than 30 scientific papers and co-authors of 2 books, a member of scientific communities of international conferences, European Commission expert in the field of energy. He successfully combined teachings and research conducted at the university with consultancy job and project management in power sectors. From 2014, he ran educational projects supported by the EU Erasmus Mundus and Erasmus Plus programs in the developing countries of Southeast Asia, including Bhutan, Indonesia, and Nepal. So Dr. Thomas, you have 30 minutes only for presentations, because we have allocated another 30 minutes later on after the third presentations for discussion. So Dr. Thomas, you have 30 minutes and the time is yours.
Thank you very much. Thank you, Mr. Fergianto, for the introduction. I welcome all students from very cold and still snowy Poland. I've seen that weather in Jakarta is very good, so you are very lucky. Let me go directly to the presentation just to save time, because we have a lot of things to share. And let's just please confirm you are able to see my screen. Is it okay?
Clear, sir. Okay.
So the topic of my presentation is the transition of the power sector. I'm working in the power sector, and this is my field of expertise. And I would like to tell you how in Europe we are seeing the future of this power industry. And looking at the energy consumption around the world, we see that energy is one of the fastest growing commodity in the world. Particularly last 50 years, we see very, very dramatic increase in energy consumption, because energy is usually linked with the economic development. There is a very clear link between the energy consumption, electricity consumption, oil, other energy carriers, and the economic development of countries. And with this, we see that there are no equal distribution of energy consumption. We see all powers like United States, like Europe, highly developed countries consuming high amount of electricity. And we still see some world regions with very small consumption. But with this, we can see some rising stars, some new developing countries where the consumption of the electricity, consumption of energy is growing very, very fast. And Indonesia is one of these countries. You can see from this map that energy consumption in old countries like USA, Europe, like, for example, Nordic countries, the amount of electricity, amount of energy we consume is going down, is falling. This is due to energy efficiency and new technologies. Instead, in developing countries, where the industry moved, when we have more heavy industry now, which left Europe, which left USA, we see significant increase in energy consumption. And with this increase of energy consumption, of electricity consumption, we see some negative impacts. And this is air pollution, including emission of SO2, NOx, ozone, and smoke emission, mercury emission. Some of these air pollutions are already addressed. And for example, emission of SO2 and NOx is quite well solved in Europe. Then we have very big problem of carbon dioxide emission, which we consider that has significant impact on climate change. Another negative impact of power industry is deterioration of water quality, which is linked to the dump of wastewater. For example, we already now discussing the case of Fukushima, dumping water, radioactive water in oceans. it will happen next days, and we are all worried what will be the impact of this event. Then we have, in the case of thermal plants, we have problem with water temperature, heating rivers, heating lakes. Then wildlife endangerment, destroying wildlife habitats, including fish, slowing river flows. Then we have problem with bat and bird migration, for example, in the case of wind power, the problem of noise, again, wind power, use of land. I will show you example of open pit mining, uncontrolled biomass farming for energy production, deforestation, and landscape, last not but least, landscape spoiling. And this is mainly related to wind farms and tourism. The consequences we see with this is in 2018, global energy related CO2 emission increased by 1.7%, reaching the highest level of 33.1 gigaton. In last year, it decreased a little bit due to the economic crisis we see due to the COVID. But generally the trend is here, and we see increasing emission. The power sector accounts for nearly 2/3 of emission growth, and only coal emitted something like 10 gigatons of CO2, mostly in Asian countries. Generally, China and India and the United States are the leaders in the emission, and they accounted for 85% of the net increase in emissions. Instead, countries like Germany, Japan, Mexico, France, United Kingdom, and other European countries, actually at the moment we are already decreasing our emission. Energy production and utilization is responsible for almost 80% of carbon dioxide emission in EU countries. In USA, the fossil fuel-based power industry contribute to air pollution and acid gases pollution, CO2, mercury, arsenic, nickel, and chromium and NOx emission. And looking at my country, air pollution, including smoke, results in significant reduction of life expectancy. And in Poland, we estimate that the share of premature deaths related to air pollution is around 23%, which translates into 90,000 people dying prematurely every year for the population of 38.6 million. And looking at some examples of the environmental footprint, we compare here two cases from Poland and from Indonesia. On the left side, you can see the largest power plant, lignite power plant in Poland, and you see how this plant changed the local landscape, agriculture. It's like the Mars, like a picture from the Mars or Moon. On the right side, you see example from Indonesia and deforestation on Kalimantan linked to the development of some industrial projects. We're still discussing the impact of power industry and the emission on CO2 emission, but for majority of people, carbon dioxide emission is very closely linked with the climate change. If you look at the top diagram, you will see the increase of the temperature, and you look at the bottom, you will see the emission of CO2. We can discuss whether there are other anthropogenic aspects or other aspects related to the climate change. But if we have any doubts, I always tell my students that we need to be neutral. If we don't know what is exactly human impact on the climate change, then we should try to be neutral as much as possible. But we see also small scale problems, which is clean heating, clean cooking, and transport. We see here examples, one example, which is related to heating. You know, Poland is a cold country, so we use a lot of small boilers, coal-fueled boilers. And this results in incredible smog and pollution in all rural areas. So we see the problem, we try to solve it. It is not easy because usually people burning coal, they are poor people, underprivileged people. They can't afford a more ecological solution for heating like heat pumps or even gas. The same kind of problem you see with cooking in Indonesia and with transport in as rich countries as Singapore, when the transport, local transport in Singapore results in dense smoke on the streets. What we can do with this, how we can solve the problem? The first is replacing fossil fuel generation with renewable electricity generation with green heat. Replacing large-scale centralized power generation with small-scale dispersed generation. We should smartly use biomass with smart farming and smart processing of biomass. Of course, energy efficiency, more efficient use of electricity, electrification of transport, but only using green electricity. We are now discussing, we are under pressure in Poland to move towards electrical transport, but we still have problem because as you can see from this picture, the share of coal in Poland is still very high. The same situation is exactly in Indonesia when the share of coal, we are both coal-based countries, but Poland is currently under pressure from the European Union to get rid of coal. And we gradually reduce amount of coal in Poland. But before that, we are not in the position to move to green transport because this green transport will be powered with the coal. Clean cooking, waste management, and of course, alternative sources of clean energy like nuclear fission, but we are still far away from this. Regarding renewable energy, we have hydropower, which is limited by the good locations for new power plants. Solar energy, which is now one of the cheapest solutions for power generation, including photovoltaics and solar collectors. We also build concentrated solar power, but this is something new at the beginning of the development, and you need very good locations for that because it takes a lot of land and you need very good weather conditions. Wind generation. We started with onshore generation. The first technology we had onshore technology, and now we try to move offshore. First of all, bottom fixed at the shallow water up to 30 meters, but the new trend is go for floating wind. And on the right hand, you can see the existing project, the new project from Scotland, which is called High Wind, which is floating wind farm, 88 megawatt. And we are now expecting many more projects like that because they are accepted by the public. Onshore, we don't like wind anymore because of the noise, because of visual effect. As you can see, the renewables are the quickest increasing generation of capacity from all possible sources of electrical energy. Then we have starting tidal and wave energy. We have very little of that. We have biofuels, for example, farming and algae fuels, and we have geothermal. Geothermal in Europe is not very popular because we don't have good location for that. But I understand that for Indonesia, this is a very good opportunity. But you need to be very careful with the environmental damage, because developing geothermal also brings some negative impacts on the local deforestation and environment. The incentive for wider use of renewable energy are falling prices. You can see prices of offshore, onshore wind, solar photovoltaics, and concentrating solar power. You can see that at the moment, in excluding carbon tax, we see in Europe, solar photovoltaics and onshore wind are the cheapest energy. They are already cheaper than the fossil fuel, which without carbon tax is a level of 0.05 USD per kilowatt. With the carbon tax, which is rising in recent years significantly, because the prices arrive in Europe now at 40 euro, fossil fuel is more expensive than even that concentrated solar power. Regarding renewables, it's not all easy. We see some problems because the generation of renewables is intermittent, difficult to forecast and schedule. So we need to change our power system and our way we use electricity. We need for this energy storage, load and grid flexibility, smart grid, and smart trading. Regarding energy storage, this technology is progressing very well, and we see old technologies like pumped hydroelectric storage. We see batteries, flywheel, large compressed air, liquid air, and vanadium flow cells, ultra capacitors, superconductive coils, and power to gas hydrogen plus fuel cells, thermal energy storage, and phase change materials. I marked here the technologies I consider the most promising solutions for the energy storage. Of course, for some technologies like batteries, we see a lot of competition in mobile equipment, in electric cars. But anyway, we think that Lion batteries will be one of the leading solutions for home storage, for home energy storage. We see the forecast for energy storage cost, and we already see that some technologies are getting more affordable. This is particularly promising in the case of vanadium flow cells, which is quite good because it's scalable. Regarding load and grid flexibility, we need load following generation instead generation following load. We call it demand side management. We need smart loads with advanced control and embedded intelligence. We call it smart appliances. We need smart buildings, smart cities, and smart heating and cooling system, and smart lighting, of course. All these things we can solve only using Internet of Things and artificial intelligence. There are our facilitators to move towards smart buildings, smart cities, and smart loads. We expect to use electrical cars as a power to grid and grid to power solution, so using them as a storage. We want to integrate power and heat generation because it is more effective, efficient. Then we need smart metering to control demand online. We need resilient and self-healing distribution systems, dispersed generation and storage, replacing large central power plants. And we need good transmission connections with, in the form of highways, cross-continent highways, or even between continents transmission highways using high voltage DC mesh networks. Regarding smart trading and local market, you know probably traditional power sector business model when utility were sending energy to customers and offered them contracts. This is the old-fashioned solution when we have all the electricity generated in the big, large coal or gas-fired power plants. And we have only customers consuming this electricity. With the smart grid, when we have all small appliances connected together and the transmission and distribution network is controlled online and is very flexible, we can arrive to the model of the smart local trading, peer-to-peer trading, where customers become prosumers. They consume, but they also produce, and they can exchange electricity between them and sell electricity to utility. So we have much more, we see much more complicated model for the operation of the retail market and generally about the power sector. Regarding EU energy policy, we try to facilitate this transition using different methods. First are directives, regulation, and standards. We see, for example, air pollution directives like LCP, which totally changed the emission level from large combustible plants. We see standards for cars, Euro 3, Euro 6. These are standards for exhaust emission of new vehicles. And with Euro 7, from 2030, we will not be able to sell any more internal combustion cars in Europe. So from all countries almost agree that from 2030, we will have only electrical cars to be sold in Europe. Then research and innovation. We have technological set plan supporting research towards new technological solutions for sustainable energy production. We have research programs like Horizon Europe, and we have very large demonstrations like innovation funds with hundreds of million euro. Then we have very, very big game changer in Europe, which is carbon dioxide cap and trade system. This system, when we need to pay for CO2 emission in Europe, totally changed Poland. Poland, as you've seen, was based on the coal. And due to the carbon taxes, at the moment, we are not in the position to continue producing electricity with coal. And we need to move to gas and more, we are forced to move to gas and other more efficient, more renewable solutions. So this mechanism really changed the profile of a European power industry. No more coal, very little gas, and first of all, renewables which are free of carbon dioxide cap. Another important point is a recent development, which is Green Deal. This is the huge post-COVID-19 economic recovery. And one of the objectives of this plan is that Europe will become climate neutral by 2050. And this is a very complex program. We see part related to industry, to building renovation, to farming, to mobility, transport, and biodiversity. So this program covers different aspects of life, including power sector. And for power sector, we European countries, members of EU, agreed that by 2050, more or less all European countries will be free of carbon dioxide emission from the power sector. Last but not least, we have education. And this is very important to properly prepare new engineers to deal with these challenges. As one of the examples, I would like to mention the project we implement currently with our Indonesian partners. Two universities from Indonesia, from Jakarta and from Semarang, which is Atmajaya Catholic University of Indonesia, and which is Soeharto Catholic University from Semarang. We are implementing project called Access. You can visit the website, which is preparing power engineering programs to deal with the renewables, smart grids, and other smart solutions to eliminate old solutions, coal-based solution from the region, from the power sector. At the last slide, I would like to just mention, because my time's already finished, I would like to mention about two strange new challenges we observed in the last years. First of all, I would like to mention that electricity consumption in Poland in 2019 was about 150 terawatt hour. And Indonesia, it was 245 terawatt hour per year. We try to change transport, and with the transport, we expect that by 2050, between 80 and 100% of transport will be fully electrical one. And this means that we will have additional increase in the electricity consumption by 2050 by at least 9.5%. And this means this is between 110 and 180 terawatt hour of additional electricity needed. So on the one hand, we want to save energy. On the other hand, we see new challenges and additional consumption of electrical energy, and this energy must come from green sources. Another big new source of energy consumption is IoT, Internet of Things, big data, and artificial intelligence. Data centers in the world in 2019 consumed almost 200 terawatt hour. And Bitcoin and other cryptocurrency transactions resulted in 111 terawatt hour of electricity consumed in 2019. If we go this way, and if we increase number of transactions using blockchain, using peer-to-peer trading, and this is the inevitable trend, this means that cryptocurrency mining will consume in 2030 approximately 404 terawatt hour. And this is 2 times more, almost 2 times more than Indonesia, and 3 times more than Poland. So we see a lot of challenges related even to the transformation we are now undergoing. Thank you very much. And if you have any questions, please save it for the question and answer session. Thank you very much for your attention. And I hope I fit in my time. Yes.
Thank you, Dr. Thomas, for the interesting talk. Yeah. So I believe that many of you going to have questions, and I apologize that to limit the flow of communication. So I'm asking you to deliver the question from the chat windows. Yeah. Later on, when the third presenter finishes presenting his talk, then I'm going to look into the chat window and read the questions to each of the speaker. So, and for that, I also need... Sorry?
I stopped sharing the screen, yes?
It's okay. Yes, thank you. You can stop it. Thank you. So besides asking question, you're going to be very helpful if you also write it down, the speaker whom you like to address the questions to. And next presenter is Doctorandus Alwar, MSc, PhD. Allow me, before I give the opportunity to Dr. Alwar, okay. Before I share this opportunity to Dr. Alwar, allow me to read his CV in brief. He has a very long CV in here. He has a lot of publication, and I apologize that we don't have the time to read all through of his publication history. Doctorandus Alwar, MSc, PhD, currently is an associate professor. He belonged to Department of Chemistry, Faculty of Mathematics and Natural Science, University Islam Indonesia in Yogyakarta. He finished the first degree from Universitas Riau Pekanbaru in the field of chemistry, Faculty of Mathematics and Natural Science. He finished and obtained a master's degree from Howard University in Washington, D.C., United States, in the area of art science chemistry department. His expertise in organic chemistry. Finally, he obtained his PhD from University of Science Malaysia, USM, also from chemistry departments in the fields of material science and environmental chemistry. He holds a number of important positions. He was head of the department from 1998 up to 2000, deputy deans from 2000 until 2004, director of a studentship from 2011 until 2014. He was the dean from 2014 until 2018, and currently he is the head of the Magister program in chemistry from 2018 until now. So Dr. Alwar, the time is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Can you see my slide?
Yes, we can see clearly, Dr. Alwar. Yes,
okay.
Very clear.
Okay. In this opportunity, I would like to say thank you very much to the UBINUS, who has given me a chance to share my research. Thank you, Mr. Ferdianto. The title of my presentation is Wastewater Treatment, focusing on the application of the activity carbon. I am working a lot about the activity carbon. Okay, before starting my experiment, my presentation, I would like to introduce my institution. I'm from Universitas Islam Indonesia. That is one of the oldest private university in Indonesia, which was established July 8, 1945. And then Now we have about 28,000 active students. Okay, this is my campus. This is the main entrance of my campus, Jakarta. And this is my entrance from Jalan Kaliurang. I think everybody know about Jakarta. And then it is the campus, mosque, and then library. And then behind the library, we have some building for my campus. Okay, the outline of my presentation is about this overview and strength. Okay. Let me start my presentation. Water and sanitation are the core of the sustainable development, and the range of service can provide underpin poverty reduction, economic growth, and environmental sustainability. However, in the recent decade, over exploitation of industry and climate change have led to reduce the water quality across the world. Okay, that is a problem. Some of in our country, climate change and exploitation of industry that produce many pollutants in the water. Actually, people must have the right to access to drinking water in the quantities and quality equal to their basic needs, as well as animals. They also need the healthy water for their basic need or their life, whether the water flow into the river or lake. Okay, water and sanitation. Right now, I think all over the world become a great issue in the world, because so many water has been contaminated by the human activities. Actually, there are two factors that can pollute water. Pollution of water, like climate change and natural disaster. And this factor, many solid solid particle due to the flood or drought or earthquake and many others, they come into the water and the water become cloudy. The turbidity of the water increase sharply. Then they can annoy the animal or plant present in the water. The second one, the over exploitation of industry. They can cause the global warming, air pollution. There are many pollution that caused by the exploitation of industry. Due to the extensive of industrialization and increase in the population density and the urbanization society, the world is faced with a problem related to the management of wastewater. On a daily basis, the effluent generated from domestic and industrial activity constituent a main cause of the pollution of receiving water bodies with a great burden on the water quality management. In general, many pollutants that are released from the industry or released from domestic can severe water and can harmful a human, plant, or animal. Okay. Actually, there are many technologies that have been used for the wastewater treatment. Like we say, the physical and chemical process for the wastewater treatment, biological treatment process, adsorption process, filtration, and many other techniques have been used to deal with the wastewater treatment. However, adsorption process is one of the most important, because it's what they use the industry to absorb or to remove or to remove the contaminant from the water. Adsorption is why they use that in the water, because it is effective, cost, very cheap and simple in the process. Most of the absorption process, they use a solid material consist of high porosity. We call them adsorbent. For example, activity carbon refer to conventional material with industry scale. It is extensively used not only for removing pollutant from wastewater stream, but also for absorbing contaminant from drinking water sources. And now activated carbon has been developed into the expand activated carbon, which is combined with the other component like metal to be catalyst. Okay, some industry in Indonesia like Surya, Mahakam, agrochemical, and other industry has produced light activated carbon that can be used for the industry. And what we call it, the largest activated carbon production is from Calgon Carbon in Pennsylvania, United States. Okay, when we see the application of the carbon, most of the activated carbon are used at the end of the process. Like here, this is activated carbon. The was put at the end of the process, because the activated carbon has very good porosity that can absorb or remove contaminants. So that's why most of the activated are placed at the end of the process. Okay, let me say about the market side of the activated carbon. The global activated carbon market side was established at the 8.1 billion in 2018 and sharply increased to 10.15 billion in 2024. And then the activated carbon market demand was more than 1,600 kiloton in 2015 and is expected to reach more than 5,000 kiloton in 2024. So what does it mean? The increasing demand of water treatment, sewage treatment application is expected to be main economic growth. So activated carbon are needed in the large quantity for the future. Okay, let me continue about the global market activated carbon. Since 2014 and the prediction to 2025, the activated carbon are needed and slightly increase every year. And then some of the country like United States, China, and Western Europe, they are need activated carbon in large quantity. And other countries also like Indonesia, Japan, and many other cities need activated carbon for wastewater treatment. And what for the activated carbon? Mostly activated carbon are used for wastewater treatment and food, processing, pharmaceutical, and medical, automation, air pollution, and many other applications can be used for the activated carbon. Okay, we start about the activated carbon. There are two types of carbon black. The first one is charcoal and activated carbon. In Indonesia, charcoal we call it arang. Yeah, there are carbon black, but different properties. Charcoal is like with black carbon produced by strongly heating of wood, coconut, at the open area, which is contact with the oxygen. You can see beside the you can see how to prepare the activated charcoal. But different with the activated carbon. Activated carbon is excellent porous material with high porosity, high surface functional group. So it can be prepared by physical and chemical process. Like, okay, let me say here how activated carbon is made. The first one, we have to find a material. Yeah, material like this. I have done with all this material, right hash. I have done to make the activated carbon from this material and to remove some of the dye from the water. And palm oil anti-fruit bun also is very good for the activated carbon. Cinnamon oil tree waste is also very good as a raw material for the activated carbon production. And then also we have done with banana anti-fruit bunch. It is a waste many the farmer just lay out at the open side this banana fruit plant. And now it's very good because it high content of carbonaceous and very good to prepare activated carbon. And the best one raw material is the palm oil cell. It's very good because we get a very high what do you call it, surface area. Okay, so raw materials we have talked about raw material and then shipping. There are two processes. Actually, there are three processes for the preparation of the activated carbon. The first one, the chemical process. Chemical process, we have to add some chemical inside the raw material, like zinc chloride, potassium hydroxide, phosphoric acid. There are many chemical can be added in the raw material to prepare a chemical process, and then we pyrolyze with higher temperature. And the physical process, we do not need chemical, but we just need what do you call the inert gas like nitrogen or carbon dioxide or what do you call that, a steam. And now we had done with the hydrothermal process. It's very nice hydrothermal process in the water, in the reactor. There is a water inside. The temperature a little bit lower than a chemical or physical process. If we compare among these, physical process need high energy to prepare activated carbon. Okay, this and then again we got the activated carbon, and then we try to crush and shipping to obtain the powder, granular or cylinder activated carbon. Okay, well, activated carbon properties. Why do we need the activated carbon? The first one, activated carbon has very high surface area. In the range of 500 to 2,000, maybe 3,000 meters square per gram. Yeah, I got in my research 2,300 meters square per gram. So it means 23 meter times 100. That is 1 gram. We can imagine if we have 1 kilogram, so we just times 1,000. So why the surface area? Just 1 gram. And some industry need more than kilogram, maybe 1 ton or maybe 500 kilogram. So that's why we need a high surface area. It's very important. So we have to find the right method, the raw material, and then for volume, it will be used for storage material, and then for site distribution. For site distribution is very important because there are three classification of the foresight distribution: micro porosity with the diameter less than 2 nanometer, and meso porosity between 2 to 50 nanometer, and the macro porosity with higher than 150 nanometer. It is very important porosity that what do you call that? To determine how good the activated carbon to absorb the contaminant. And then beside the physical properties, high surface area, porosity, for site distribution, we call that physical properties. We also have the chemical properties like very functional group. And there are many functional group on the activated carbon. And then physical and chemical absorption, they can absorb contaminant or material by physical and chemical absorption, and now easily modified using metal ion. So we can combine the metal to be, with the activated carbon to be composite. Okay, let me see. This is some of the functional group that attach on the surface area of the activated carbon. We can find the carbonyl, lactone, phenol, carbonyl, carboxyl. There are many other functional group. that is very important to design the interaction between adiabatic carbon and adsorbate. It's very important a functional group. Okay, adiabatic carbon can be separated into three types of powder adiabatic carbon, granular adiabatic carbon, extrude or cylinder pellet adiabatic carbon. So there are many applications of powder adiabatic carbon and granular adiabatic carbon. Okay, let me see how the adiabatic carbon works. Adiabatic carbon work by the adsorption process. Adsorption can be defined as a process in which material, whether pollutant or dye or heavy metal, as the adsorbate, they travel from a gas or liquid phase and form a superficial monomolecular layer on the solid or liquid condensed phase substrate. Okay, there are from this we can show that two type the interaction between the adsorbate and adsorbent by chemistry, chemisorption or physisorption. Of course, chemisorption is better bonding between adsorbate and adsorbent. So most of chemisorption occurred on the microporosity, not macro, but microporosity. That's why we need to design activity carbon with microporosity. Okay, and then how to define the quality of the activity carbon? There are many instruments we have done to design that, like thermographic analysis. We have to find how much carbon content on the activity carbon. Gas absorption analysis, they can be used to determine the surface area, pore volume, pore size distribution. We can determine with this. Scanning electron microwave energy dispersed X-ray, SMADX is very important to see the surface morphology of the activity carbon. And then FTIR for the infrared, we have to analyze with this instrument to determine the content of functional group that attach on the activity carbon. And then X-ray diffraction. When we want to add metal on the activity carbon, we need this instrument to design the crystallinity metal and activity carbon. And then TEM also we need for the determination of them. Okay. Let me see some experiment that I have done. Yeah, for this thermographic analysis. Yeah, we got this. So what does it mean? It means only all the component has been changed to to carbon. Yeah, so this what we call that low molecular weight like water or gas, and others compared to carbon. And there is some result, and we got this with we have done with 3 chemical activation with zinc chloride, potassium hydroxide, phosphoric acid, like this. Okay, so the result like this, I think it's very nice result because carbon content more than 80%, roughly more than 80%. And then the result for the carbon, yeah, this obtained from the nitrogen adsorption, desorption, gas absorption analyzer. We can know about the type of microporosity. This microporosity, and at 100 degrees there is a little bit of mesoporosity. So we have designed the adiabatic carbon with micro and mesoporosity. And here the instrumentation with FTIR is very important to determine what kind of the functional group attached on the surface of adiabatic carbon. Here some of the same ADX morphology structure from palm oil cell of adiabatic carbon.
Pak Arwad, Ada sedang mute itu, Pak.
Okay, this same result. We got some of the porosity. The highest surface area we get the 2,300 more than that. It's very nice. Yeah, very nice product. We got this. Okay, and then also here by physical absorption, very nice porosity. We got the highest surface area. We got a 900 more than 900 meters square per gram at 900 degrees. Okay, let's continue. This is the interaction. Okay, the active particle carbon. How the active particle carbon can bonding what do you call that pollutant? Pollutant. They can make a surface complexation. So if the pollutant in the water is heavy metal like zinc, copper, cobalt, nickel, and many other heavy metals, they absorb the metal by forming a complexation. So water has been polluted by the heavy metal. We need this active particle carbon to bond the metal by complexation. And then also by electrostatic interaction. This, the most important, we have a functional group. So they can absorb like a dye, rhodamine B, methylene violet, methylene blue, and other dye that present in the water can be absorbed by this process, by electrostatic interaction. And also interchange. It is very important in the wastewater treatment for drinking water. Most of drinking water they use active particle carbon to do the ion exchange process. Okay, and then physical absorption, and then the precipitation to accelerate the contaminant to precipitation at the lower bottom. Okay, this is a group, functional group. Okay, what is the problem? Preparation of the particle carbon with high temperature usually will release some of the functional group. Functional group is very important, but due to the high temperature, some of the functional group release. That's why we have to recovery the presence of the functional group. So by adding some chemical like phosphoric, sulfuric acid, nitric acid, and many others here to recovery the functional groups. From here, we see that some of the functional group occurred here, and it's very important. And H and H2, say N, and many other, maybe OH also we will get in the on the surface functional group after modified with the chemical. Okay, this is the interaction absorbent and absorbent, absorbate and absorbent by three methods: by formation of complex, and then interaction between a molecule. In this section, the absorption occurred by physical process, by van der Waals interaction, and functional group interaction with interaction occurred by chemisorption process. Highly bond occurred between absorbate and absorbent. Okay, this is one model of the methylene violet that has been absorbed by the active particle carbon. The most important here, the interaction between methylene violet with the surface functional group oxygen here, with the nitrogen with the positive charge. Okay, the next type of metal ion active particle carbon. What did I do to develop the active particle carbon? I have prepared the active particle carbon from the palm oil cell. You can see the sand here. It's very nice porosity. And then when we add some of the chemical like aluminum oxide, we got very nice figure, very picture here, like a flower. What does it mean? It means the aluminum oxide has been attached or loaded on the surface of adiabatic carbon. So it can increase the presence of functional group. And this adiabatic carbon has been used to remove the methylene violet. And then also here, TiO2 fiber from empty fruit banana, banana empty fruit buns. We call that in Indonesia tandan pisang, yeah, which was effectively used for removal of rhodamine B. So this is fiber. After we add a TiO2, some metal here is very important to increase absorption process. And also here from a banana fruit bun, with the nickel oxide, some of nickel oxide attached on the surface area of the adiabatic carbon, and also here from the cinnamon buckwheat. Yeah, this is very nice cinnamon buckwheat. Usually the cinnamon bug just throw away at open area, but now we try to convert, become adiabatic carbon. Okay, and then what else? Now what is my project? Adiabatic carbon is not only used for the separation and purification of water, but it has been used to produce catalyst. By combination of the carbon with metal, I have used this metallic adiabatic carbon, NiCu adiabatic carbon, for hydrocracking process and isomerization process. So what did I do? I used the palm oil to convert palm oil to gasoline. So here the palm oil without adding catalyst at the 650 degrees, there is no peak at the lower 10 time. It means that no product having low carbon. So the carbon content is higher than 15, 12 to 15. But after I add catalyst to convert the palm oil to gasoline, we got so many peaks at lower retention time. What does it mean? It means there are many new products produced after adding catalyst. So at the retention time, peak 1, 2, 3, 4, 5, the product is carbon with a C, with carbon 6 to 10. It means gasoline, normal hexane, normal pentane, normal heptane, and normal octane we got from this result. So what does it mean? It means activity carbon not only used for the water for separation or purification, but also can be used as a catalyst. And also we use for the photocatalyst to degradation of the dye. We have done right now, but we don't have the good result yet. Still, my students still working with the project. Okay, I think that's all my presentation. In conclusion, activity carbon is excellent porous material that can be used for many applications such as separation and purification of water. The requirement of activity carbon for wastewater treatment are needed in a large quantity for wastewater treatment. Modification of activity carbon to new performance may improve their physical and chemical properties. And new performance of activity carbon for catalyst provides multi-application for the future life. So the most important, we have many raw material. Indonesians have many material to prepare adiabatic carbon. The most we have to define, we have to develop the method, we have to find the new raw material, and we have to get good analysis to obtain the quality of adiabatic carbon. I think thank you. That's all my presentation. Thank you very much. If any question, I return to the moderator. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Alwar. Excellent, excellent talk on these activated carbons. Yeah, honestly speaking, that's I always bring with me activated carbon in a tablet form. A product that I often use is called Norit. It's a very traditional one, and you know. I had been living in a few countries from Japan to Europe, and I always bring with me these activated carbons because I find this medicine is extremely useful. And in fact, it saved my life a few times. So listening to your presentations is just make me more understand the basics, mechanics or chemistry, why this activated carbon is so useful. Thank you very much for that excellent talk, Dr. Alwar. So yeah, without further delay, let's move on to the next presenter, Dr. Tota Pirdokasi. And before I surrender the time, allow me to read his long CV. Dr. Tota Pirdokasi started his professional life as a research assistant in 2002 to 2006 in the chemistry department, Gunma University in Japan. Then from 2006 up to 2009, he was a plastic engineer, research and development, Mitsuba Corporation in Japan. 2009 until 2014 as an assistant manager laboratory, PT Astra Daihatsu Motor. 2010 until 2014 as a lecturer, Mercu Buana University. 2014 until now is a lecturer specialist in industrial engineering, Venus University. And from 2017 until now, he is a head of a professional engineer study program, Bina Nusantara University. He also has a very long educational history, bachelor's in chemical engineering from University of Indonesia in 1998. 2003, he obtained his master's degree from Gunma University in material science. And finally, in 2006, he obtained doctoral degree from Gunma University, also in material science. He has a very long publication history and has a research interest area in the plastic engineering, manufacturing, quality, and optimizations. So, Dr. Tota, the time is yours. Dr. Tota, can you hear me?
Yes. Is my voice is clear enough to hear? Hello?
Yes, clearly. We can see.
Clear. Okay, clear. Thank you. And you can see my presentation, right?
Absolutely.
Okay. Thank you, Dr. Fergianto, for the time for me to deliver. And I also want to say thank you to Mr. To Community Development Academic, Binus University, managed by Ibu Retno, for allowing me to deliver this theme of ecology. So my presentation title is Combating the Plastic Waste by Converting It into Liquid Fuel. So regarding to the plastic waste, some information is like this, that 175 kilotons of waste produced in Indonesia, and 14% or 24.5 kilotons of each is in the form of the plastic. That's for a day. But unfortunately, 81% of the waste in Indonesia is unsorted, making it difficult to recycle, and it was combined, mixed, and then so on, causing the plastic waste to end up in landfills. So this is the very bad for the landfill for our planet, and also the make it worse is that the plastic waste was leaked into the ocean. We know that the plastic takes 100 of years to degrade, and also the plastic in landfill and ocean will continue to pollute for several generations. 20% of the plastic waste in Indonesia is believed to end up in our rivers and coastal waters, or it is equal that every 20 minutes, the equivalent of 10 tons of truckload of plastic waste is dumped into the Indonesian waters. We can imagine how pollute our water, Indonesian water is it. So because of this, Indonesia becomes the world's second largest contributor to the plastic pollution in the ocean. All of this information make that the plastic waste is a very serious issue to Indonesia environment. Maybe not only Indonesia, but for all of the world. So regarding to the environment problem due to the plastic waste, it is our responsibility. Government, from the government, industry, plastic manufacturers, university, that we are faculty members, and also the society, consumer, until the individual person. We must have to work together and play an active role to solve this problem. So as a solution to the plastic waste, we generally know that the application of the reuse, reduce, and recycle, the 3R we generally know as a 3R system, is one of the solutions in protecting the environment around us. Why? Because they are cheap and easy to do. Everybody can do, every society can do. In addition to the processing waste into liquid fuel or using waste, the plastic waste as a source of electricity or waste power plant. A little bit information about the plastic waste management about the 3R. The first R is reduce. Know that there is a regulation, strict regulation nowadays that not preparing the plastic bag in mini market we can found, and in mini market, supermarket, restaurant, or shopping centers with no preparing of the plastic bag. This can tend to reduce the use of plastic. Also, the more slogan about a better way to reduce waste is not creating it. Other is only buy what you need. So this is also how to reduce the plastic waste, the utilization. However, we also see that there is a lot of increased plastic use for coffee cups, because maybe nowadays we can find so many of coffee shop which is using coffee cups. And then also new plastic for the product of snack packaging, bottled water, and variety food pack, and etc. This kind of plastic can be turned into the plastic waste instantly. And the second plastic waste management, second R is reuse. Reuse looks at how you can use a certain item again, or ideally multiple times. You can use it in multiple times before replacing them. So the example of reuse, such as look for the item that you can reuse. So, for example, water refill container, instead of new plastic, you use plastic to get the water. And then choose the reusable and environmentally friendly bags instead of the plastic bags. And then update the computer rather than throwing it out and getting a replacement. And the third R is a recycle. Recycle is about separating items that can be recycled of course, meaning they can be used for a new purpose. For the example of the recycle, like a plastic bottle from PET, it will transform firstly into the dacron, and from the dacron into the fibrous yarn before it transfer or to make it a polyester cloth, such as sweater and so on. Also, the shampoo or lubricant bottles, as I know, this is from high density polyethylene. It can be transformed into the shopping bags like this. The other is beverage cups or straw that can be turned into woven bags and other housewares. And also the multi-layer plastic. This is the hard to recycle plastic example that can be transformed into the asphalt plastic road. So other solution beside of the 3R, we can explore process technology as an alternative solution to the plastic waste that could be transformed post-use plastic, or even for the hard to recycle plastic, into a useful liquid fuel that could be used as a source of energy via thermal heating techniques. This method or thermal heating techniques called pyrolysis is a thermal decomposition of raw material or plastic waste into a gas in the absence of the oxygen. So if the gas is condensed, it could be turned into liquid fuel. Just remember that all of the plastic are originally made from oil, fossil fuel, fossil resource. So this process bring them back to its original form. By using the pyrolysis method, it also has advantage to solve the twin problems. The first problem, to solve the environmental pollution due to the abundant plastic waste or plastic pollution. And then the second, the production of alternative fuel for energy resource as an alternative to the fossil fuel. So why we choose plastic waste to liquid fuel as an option? This is the data that I want to share, that it was found that less than 5% of manufactured plastic is recycled each year. So we can imagine what about, how about the 95% another. So the facilities in the plastic to fuel transformation could bring the potential to upward almost 40,000 new jobs and almost $9 billion in economic output. This kind of things could improve, of course, our economy, while also providing new ways to reduce plastic waste and getting liquid fuel. This method could also be cheaper than current recycling methods. Currently, the recycling method, it costs upward of $4,000 to recycle 1 ton of the plastic bag, which sometimes or often leads to burning plastic or disposing of it in landfill to avoid this high expense. This is a quite expense, of course. So also this type of chemical recycling method is also much simpler in design, simpler in process. When you heat everything up at the high temperature, there's no need to pre-sort the waste. This pre-sorting or cleaning the plastic waste sometimes really time-consuming process. So as a description of a pyrolysis process, we can see it's very simple. This is the simple schematic diagram. We can put the plastic waste into the reactor or the container here from the stainless steel, and the plastic waste is heated by heat transfer, we can use a burner here or by using electric heater, and then bring the thermal decomposition of the waste, forming a mixture of a vapor and gas and the carbon residue. The carbon residue, of course, because of the not complete reaction after burning. The maximum operating temperature is about 400 to 500. We know that all of the polymers will be decomposed all below the 500 degree. The reactor lid in upward position is manufactured with a special design. This provides to complete closed system, make it sure that it is a complete closed system to avoid air inclusion to the reactor. Remember that this process can be occur without oxygen. And then vapor gas mixture goes through the pipeline, cooled in the condenser or cooling system. And then the pyrolysis oil will be collected in this collecting beaker. So at the end of the pyrolysis process, some carbon residue is unloaded, should be unloaded first to make the reactor more clean before for the next batch of pyrolysis process. So actually what happened during the pyrolysis process, we know that at the temperature 120, the vaporization process of all water content inside the reactor will be happen. This is because the plastic that we insert into the reactor, we have no pre-sort or cleaning with water. So at the temperature 120 degree to 250, there's a cracking process occur in which that the carbon-carbon bonds will be decomposed to more light hydrocarbon from a long chain and heavier feedstock, which is the plastic itself. At a temperature 250 to 400, 500, those light hydrocarbons vapors into the pyrolysis gas through the pipeline to find the way out. And then when the smaller hydrocarbon gas passes through the condenser or the cooling unit, it will convert it into the pyrolysis oil or liquid fuel. Yes, last year, last December, there's a community development, we did the community development activity led by Ibu Religiana Hendarti from Architecture Department. We create and we produce a very simple pyrolysis system, and we make a performing test of our pyrolysis equipment on one community at Meruya Selatan in West Jakarta. So please take a look this video about our activity.
Pak Tota?
Yes?
We can't see the video. Maybe you need to share it first.
I'm sorry?
We cannot see the video.
Oh, you cannot see the video. Okay, yes. Okay. I should stop share this and make. Wait. Can you see?
Yes. Now
okay.
It's good. It's clear.
Okay, thank you. This is our pyrolysis system. mulai lihat tetesannya. Nah ini dia, kita bisa lihat. Nah ada airnya. Nah itu nanti sampai itunya habis yang 8 kilo. Semoga kita bisa mendapatkan nanti cairan liquid fuel-nya sekitar 3,5 liter. Kira-kira. We test the liquid fuel for the burning test. Okay, we go to yes, the result from our performing test of our pyrolysis, we found that if it using moderate burner, the drops of pyrolysis oil would come after 60 minutes after thermal heating. So the time will reduce to 20 minutes if it using a double type burner. Of course, the gas fuel will be sold fastly. And then time to start the oil drops will become shorter if the plastic waste was firstly cut into the small pieces. And from 3.8 kilogram plastic waste, we can get 1.5 liter of the liquid fuel, or in efficiency almost 40%. If the plastic waste in the form of polyethylene, this is the interesting that we found, that if the plastic waste in the form of polyethylene or polypropylene, we usually use this material of polyethylene or polyethylene for the plastic bags, packaging, and etc. The drop of fuel is liquid. However, if the plastic waste is a type of plastic bottle, the material is the polyethylene terephthalate or PET, the liquid fuel will turn into like a pasta after more than 10 minutes in ambient, even in ambient. So it will become like a solid, a pasta solid. So regarding to the cost, it costs around 20,000 rupiahs or $1.4 for the gas burner to heat, yes, for one batch, 5 kilo plastic waste for one batch. This is for the 70 liter of the reactor. And then the liquid fuel produced could be used for other batches. As a conclusion from this activity and this presentation, that in addition to 3R system, pyrolysis method could be potentially utilized to combat the plastic pollution as well as the production of alternative liquid fuel for energy resources. It could apply in community as well as to educate the community concern and awareness about the plastic pollution. This is the education goals is more important. And then kind of low cost process, it's about 1,000 per ton, when the other for the recycle of 4,000 per ton. And the pyrolysis method is simple and easy to do. As we can see that the video, there's no need of pre-sort for the plastic waste, just heating everything up at a high temperature. Then the pyrolysis method is also potential to open many new jobs and bring to the increase for the economic output. And the last, of course, we have to optimize the process, should be as our challenge to comply the continuous strict regulation and pollution control technology. That's all of my presentation. Pak Fergie, I bring it back to you. Thank you very much.
Thank you, Dr. Tota. Very interesting projects about the further use of plastic waste. Yeah. Okay. Now the three presenter has finished presenting their interesting topics, and now let's open and have discussion sessions. I saw that a number of students has delivered their questions, and I'm going to read the first ones. The first one is from Louis Pratama. The questions is addressed to Dr. Thomas. The question is as the following. My name is Luis from Bina Nusantara University. I have a question about solar energy. In your opinion, is solar power still applicable in Indonesia? Because I see that the price is more expensive than the monthly electricity cost. Then how can Indonesia apply solar energy if the price is more expensive than the monthly electricity cost? Dr. Thomas?
Okay, thank you very much. I already tried to answer this question in the chat. I hope you can hear me. You can hear me, yes?
Yes, yes, we can hear you clearly.
Price is very important. And in case of Poland, photovoltaics is now the cheapest solution because of two things. First of all, the price of solar panels is reduced during the last last 5 years by almost 50% or more, even more. So the cost of the installation is now very low. The second point is that our government, like other governments in Europe, try to increase cost of coal energy. We have a carbon tax, and the carbon tax cost is now approximately 40 euro per ton, which is additional 40 euro per 1 megawatt of electrical energy, 1 megawatt hour of electrical energy. With this additional cost, PV is less expensive than coal, and Poland in the past was dominated by coal. In the case of Indonesia, if PV is more expensive, there is no way that you will go for this solution. You might apply this solution in the remote areas when you have diesel generation. I visited a number of remote locations in Indonesia, included, for example, the most beautiful part of the world, which is Raja Ampat. And I see a lot of highly polluting diesel generation on small islands. These are very small, dirty diesel motors running through all the night in the resorts and in small settlements. And this is the direct way to replace these small diesel motors with small PV installations and small storage. This is the off-the-shelf solution, very simple and economic. And even if you still promote coal, which is, I think it's wrong, because you will face the danger of the tax, carbon tax, exporting your goods to European countries and USA, and soon also China, if the carbon tax is introduced to the world trade. But this is your policy. I understand we have the same question in Poland, that we try to save our jobs in the mining industry, in the coal. And the coal means also independence, because we have coal. But of course, this is the strategic choice. At least I believe in Indonesia, you can start installing PV in the small villages, remote villages, isolated islands, when there is no access to power grid, to utilities, and the cheap energy from coal. This is the only solution.
Thank you. Just for a very short follow-up questions. As you mentioned that in that remote area, they decided to use diesels as a source of energy instead of, say, some renewable form. What is the constraint they have, you think, for them to make that decisions?
The main point is that if you run diesel generation, then you have constant supply of electricity through all the day, also during night. So if you go for PV is producing only 6 hours per day. And then you need to save this energy. You need to store this energy for the use during the night. So installing in these locations PV only is not feasible. You need to combine PV with storage, with some kind of batteries, couple of kilowatts of batteries, and then you will be able to produce it during the day and use during the night.
Can I say that in terms of practicality, that it is much more easier for people to get the energy from diesel instead of from, say, PV power? Can I say that in the current market conditions?
Yes, absolutely. You are absolutely right, because it's very easy to buy small diesel or small generator, gas fuel generator. But this is not ecological solution. We are talking here about the ecological solution, burning gas and burning oil contribute to the emission and pollution. So if we want to keep Raja Ampat clean and beautiful place, and also silent, because this is the question of noise. If you spend your holidays on these islands and you hear all the night running diesel, this is quite frustrating. So I know that this is the cheapest solution now and the simplest solution. But if you want to move forward, not always cheapest solution is best for you. Sometimes to get to the next level, you might to face challenge and solve challenges.
Okay, thank you. Thank you very much, sir. I think the answer is excellent. Okay, let's go and check for the next one. I think the next one is addressed to Dr. Tota. Is there any more waste after the process of a plastic waste, the one with pyrolysis, I guess?
Okay, thank you for the question. So incomplete reaction of the pyrolysis process, of course, from our experience that we pyrolysis 3.8 of plastic waste, and we only get 1.5 liter of liquid fuel. So the other mass should be due to the incomplete reaction, and maybe somebody or someone will call that waste of the process. So how about this waste, the residue, the carbon residue as a waste? It could be utilized as like a reinforcement for the asphalt for the road. And we can mix also after we put some thermal heating into the residue, and it will becomes not very hard. And then we mix it with the asphalt, and it can be utilized for the asphalt roads. I think that's the answer for the question. Thank you.
Thank you, Dr. Totek. Excellent answers. Okay, before I move ahead to the next questions, I'd like to remind the audience to fill the attendance list, because it's kind of important for you. In order for you to get a certificate, you must fill the attendance list, okay? Yes, and the next question is for Dr. Olwar. It's about this wastewater treatment system by activated carbon. Do you think this is suitable to be used in, the, say, like a flooded area where you practically have water but contaminated, but there is no clean water? Do you think this is a solution for a case like that? Dr. Olwar, can you hear us?
Okay, thank you. Thank you for the question. Yeah, actually the adsorbent from the activated carbon can be used to separate or to purification of water. That is most important thing. We have to know that. So that's why it can be used for the many type of water. For example, water for the drinking water. So we can use the activated carbon with special condition, not the same with the activated carbon for the industrial waste. For the activated carbon for drinking water, we have to get very good quality. There is no contamination in the activated carbon. So for example, we should have with the micro porosity. But for industry, so maybe the quality not as good as for the drinking water, I think. Because we need in the large quantity. For example, we need 100 kilogram. All the waste of the industry can pour on the activated carbon, and then they absorb all the contaminant. And then the rest of the residue, the rest of the water can be released on the stream. That is very important. So that's why preparation of the carbon also we have to consider. If we want to use to drink water, we cannot use biochemical, right? Biochemical. Or if we want to use we use to be the chemical, so we have to make it neutral, no chemical effect on the drinking water. This is very important, I think.
I see.
Oh yeah.
Oh, thank you very much. So it can be used in that condition. I mean, in the condition of flooding, then we can use these activated carbons to obtain a clean water. That's and right. It's also healthy, huh?
Yeah.
Okay. Okay. Thank you very much, sir. One more thing, just a short follow-up question is, do you think we need to add sort of activated carbon in the water we obtain from the government, from the PDAM? Do you think it's necessary or not?
Oh, yeah. Right now, the activated carbon has been used in wide process. Let me see what the name there. We can find the purification water in home, right?
I see.
Yeah, there is a activated carbon inside, right?
Nice.
And also, you want to see a refrigerator or air condition. Right now, air condition has been put some of activated carbon inside. So the dirty air absorb by the activity carbon, and then they release a very good healthy air. So there are many activities can be used. I think this would be good in the drinking water or industry or pump, for example. I think it's very much better. We can put at the end of the process, not the for the first, but the end of the process, because it has good porosity activity carbon.
I see. Thank you very much. So, would you provide a recommendation? You think that is it recommended things to do for us to have like a personal water treatment at home, even we get the water from PDRM? Do you think that's a kind of an important thing? Yeah.
Yes, of course. Yeah, yes, of course. We should give recommendation to use that activity carbon.
I see. Thank you very much. It's a very useful recommendation. I believe a lot of people has an interest in this issue. Yeah. Okay. And yeah, we have a lot of questions. And one more question. The last one is addressed to Dr. Thomas. The question is from Christy Stephanie. And she like to know, is it possible for 100% renewable energy to power the world in the future? Good questions.
Yes, thank you very much for this question. This is the most important issue now we are facing. Yeah. And of course, if you go for only 100% renewable without storage, this is infeasible solution, because as we discussed, in case of renewables, we need to follow generation and we need to adjust our consumption to the generation changing, fluctuating generation. And this is not feasible because we consume energy on demand. So the only solution is to have a backup in the storage. Again, we need some kind of storage. It might be large scale storage, like hydro pumped storage, or it might be small scale storage. We are now facing transition to green transport, and we see opportunity in the EV cars, which will be part of our storage system. Without storage system, you need background in fossil fuel generation or other kind of generation. So we have two solutions: storage and flexibility of demand. For the flexibility of demand, you need to adjust your consumption. And this is quite difficult. Of course, we can use also thermal storage because, for example, we use in Europe electricity for heating. And if you are able to store heat energy during high production, then you can use this heat or cool, in case of Indonesia, when you need it. So 100% renewable without storage is not possible. We need a combination of renewables and storage, thermal storage, electrical storage, power to gas, gas to power. I didn't talk about the hydrogen, but another transformation is the transformation of transport to fuel cells and hydrogen. And for this, there is another opportunity of storage, power to gas. Thank you very much.
Thank you. Thank you. Unfortunately, we have reached the ends of the sessions. And before I close this session, I like to provide a short summary about the important aspect given by our presenter. I apologize if my summary lack of accuracy. First is from Dr. Thomas. I outlined a few important aspects here. He talked about the transition of energy, and he mentioned that energy is a fast growing commodity. And with the increase of the energy consumptions, we have a number of implications we see, for example, noise, pollution, premature death, and wildlife, and so on. And the second, he talked about green energy productions, including geothermal, wave energy, hydro, solar, wind, biofuels. And also he mentioned that Indonesia has a great opportunity with geothermal energy. And another issue he mentioned, the necessity of development in energy storage, for example, battery. And finally, he mentioned about the use of smart technology in order to better manage energy. And the second also a great presenters is Dr. Olwar. And Dr. Olwar talked about water contaminations and sanitations. And he mentions about a number of water treatment technology involving absorption process and activated carbons. Related to activated carbons, Dr. Olwar talked in the great details, including the growth of the market, manufacturing process, types, microstructures, and working mechanisms. And the last speakers, Dr. Tota mentions about the challenge we have with plastic waste and also solutions involving the 3R, reduce, recycle, and reuse. And finally, he demonstrated the use of a pyrolysis technology, not only to reduce the waste, but also to convert the waste into energy. Okay, so that is all that I can summarize from these talks. And before I close the sessions, I like to invite you to provide a great applause to our speaker. You can see there's a clap buttons at the right corner, and please give it a click. Yeah, thank you very much. So before we close these presentations, one more thing I need your help is to turn on your video so we can take documentation in terms of photo. And I believe one or two staff from CDC may like to help you to take a photo of all participants.
Yes, please. Let's take a group picture. But first of all, I want to remind you that I want to make sure that you have filled out the attendance link today, and also the questionnaire link, because we need your attendance for the e-certificates matter. Okay, so if you have, let's take a group picture. Kindly turn on your camera, please. Okay, so we have 12 slides here, so it will take some time. Right, the first slide, 1, 2, 3. Okay, wait. All right, the second slide, 1, 2, 3. Hold on a second. The third slide, 1, 2, 3. Next slide, 1, 2, 3. Okay, next slide, the fifth, 1, 2, 3. Sixth slide, 1, 2, 3. Okay, next slide, 7, 1, 2, 3. Next slide, 8, 1, 2, 3. Slide number 9, 1, 2, 3. 3 more slides, hold on. 1, 2, 3. 11, 1, 2, 3. Okay, the last slide. 1, 2. Wait, the slide 1, 2, 3. Okay, thank you.
Thank you. Okay. Yeah, I'd like to offer my highest appreciations to Ibu Retno Dewanti and Team CDC. Thank you so much, Bu, for working hard, making this event possible. And also thanks to the three excellent speakers, Dr. Thomas, Dr. Olwar, and Dr. Tota Kasih. Terima kasih banyak. And to all students and also faculty members. Yeah, I wish you the best of Ramadan, and I'll see you again in the next event. Thank you so much and goodbye.
Thank you so much, Ibu Retno. Thank you so much.
Thank you, Dr. Awan, Pak Ferdi, Dr. Toto.
Thank you, Pak Ferdi, Pak Tota,
Moderator, Dr. Ferdi. Thank you.
Dr. Thomas.
Bye.
Now the participants that joining us here.
Thank you, Pak Wisnu. Thank you to all.
Terima kasih. Sehat, sukses selalu untuk semuanya.
Amin. Thank you.
Is it okay? Pak Wisnu, apakah sudah boleh pamit ya?
Sudah boleh, Pak.
Sudah, oke.
Sudah selesai. Terima kasih.
Thank you, Pak Wisnu. Pak
Terima
Ferdi,
kasih banyak.
thank you banget. Thank you.
Thank you. Sip, good, excellent. Thank you, Pak Wikarya.
Pak Wikarya.
Terima kasih sudah hadir, Pak.
Izin live, Bapak Ibu.
Ya, mohon izin. Thank you.
Silakan, Pak.